let me remind you guys the schedule. This is tentative schedule for the rest of this semester. Uh, I think some of you noticed, but some may not. What we will do is we're going to meet Tuesday here in person, Thursday online for the rest of this semester. I think maybe 3 or 4 weeks. So today in person in class, and Thursday online asynchronous. Likely next week, Tuesday we meet here, and Wednesday you take this class from home. It's not even Zoom, but I am going to post my recordings. Okay, so you take my recordings at your pace. You don't need to come Thursday. So Tuesday you come here, Thursday you don't need to. And Thanksgiving Thursday, no class. We are not going to even online class. And then in January, the first week, first Tuesday we meet here. First Thursday, that's online. And then I'll give you the second week, that's a study day. Like for our midterm, during this study week, we will set up Zoom. If you want to know something about your final exam, please join. I'm not sure how much help you guys for your midterm exam. Who was in my Zoom? You were there, right? Right. I think it helped. Yeah, helped. And then our final exam is December 16th. This time, online exam. You don't need to come. Okay? One of the main reasons is that for midterm exam, we set up 3 official time slots, which is spread out the students, maybe okay. But the final exam, we're not going that way. We do not have enough time to make 3 different options. Even if for 3 options that I provided, I had also Saturday, Manhattan, we have a group of other students who do not come here. So we had the exam. And also Sunday, I have the exam, midterm exam. There, we use this, lockdown screen and camera. Only the issue from my experience on Sunday exam, a couple of days ago, the students said, we need to disconnect the Zoom. I'm not sure. Is it true, or have you taken any the lockdown and camera test on the Blackboard and also Zoom? Everything on fine?
But after 30 minutes, the Zoom cut off.
Zoom is off, right?
After 30 minutes. So
Why 30 minutes?
Zoom, I don't know. It's just after 30 minutes, the Zoom cuts.
Oh, anyway, Zoom and a Blackboard with the lockdown and camera never go together throughout, right?
Yeah, it's a little annoying.
Right.
It's like, it wasn't, it doesn't flow well unless you have maybe a second screen. It's like.
Okay. So maybe lockdown screen and camera only. Zoom, I would say, when we start, I collect you all on Zoom, and then Zoom will be out when you start your exam. I think that is the way that we will do. So for your final exam, that is online exam. Okay. That's. Any question about this schedule? So the basic principle is Tuesday we meet here in person. Thursday you stay at home and take my class. It's not Zoom. I am going to post my recordings. So whenever you have the questions from Thursday, the class recordings, bring that to the following Tuesday so that we can cover that. Question, Melody?
Levi and I have our statistics class that we get out at 4:10, and going, like, we have to stay here still for the online class.
What do you mean by that?
Yeah, because we can't go and take the class, the online class on our phone because,
No, it's not. It's not async. It's not synchronous. Asynchronous.
It's
okay,
asynchronous.
never mind.
Asynchronous. Right.
Thank you.
Any other questions about that schedule? Okay. So when I came here today, I think, oh, my schedule is so good because of the weather. It's so cold to come here. So at least, 2 times commuting under cold weather per week, maybe not pleasant. So, set up Tuesday here and Thursday at home. Okay? And today also we're going to practice at the first time group lab. Group lab. How many of you now activated your Raspberry Pi? So I think at least one group has one Raspberry Pi connections. You have a Raspberry Pi here?
I have mine.
I mean, right now, you have a group. So maybe 3 groups. One group here, group there, and one group here. Okay? So a little bit of the first time of group lab. If it's not complete, then you can take it home and complete. That will be your homework assignments, okay? Your group collaboration today will be your the homework assignments. Submission of your homework assignments is not by group, individual. But I want you to work together. Okay? All right. So that is somewhere here. Yeah, this is a group work. Okay? See here, group work, IP commands. So there are 3 questions. So you need to answer those 3 questions with your evidence screenshots. That will be later. All right, before we go there, and this is what we want to do. Okay, so network is very, very important, right? Particularly when you learn Linux administrations, then that is a core part of your network administrations, and cybersecurity professionals needs to take care of networks. So all the informations and information sharings coming through the networks. So today we will start with that practice, and hopefully we can complete on this Thursday. One beauty of one time in person and one time online is that I can manage my class. Well, by that I mean, if I do all here, then according to the time, then I need to stop all the time. But when I record my lecture, for example, for the Thursday portion, I can manage it, and I can post it, so that I can manage it, the classes very efficiently. So hopefully we can finish network management today and then Thursday, 1 week. Okay. So what we need to do, these many things. Okay. So view network configuration, test the internet connections, view routing tables, display all. But this is so many things, almost unlimited the handlings needed. But in this class, we are going to do a little bit of those, particularly IP. IP is a command IP. So we'll look at a little bit deeper level of IP commands, which means is that IP with some options. So you may be able to see some interesting result. First thing that we need to do is to IP address, right? So how can you get the IP address in normal Linux? The command is, like I said here, IP A. So IP A, then we can see the IP address. If you see here, I wanted to see IP address returns us three the information in 3 blocks, right? It is a labelings here, number 1, number 2, and number 3. 3 blocks of information. First one is LO. LO stands for loop back. And next one is Ethernet. Right now, if you connect with your Ethernet cables, category 6, category 8, whatever that comes here, my laptop does not have Ethernet ports, but our Raspberry Pi has Ethernet ports, luckily, right? So then you will have that Ethernet information. Right now it says no carrier, which means I do not have Ethernet connections. Right now we have WLAN. There's a LAN, local area network. W means wireless, right? So our Wi-Fi connections, the information about Wi-Fi connections here in number 3. Okay, so that we can do broadcast, multicast, up, lower, up, and MTU. I think it's a maximum transfer units, something like that. Some of the informations of that. For example, what is the state of WLAN? Then it says up. What is Q disk? Whatever that is. I want you to find out this. MTU, as I said, the maximum transfer unit. Not receiving is something different, right? And then there is a group. What is a group? Default. What is queue length? Wireless LAN, when the network and the packets coming in, then the packets may stay in a queue. Queue is a data structure that handles first come and first out services. When packets arrive, then as the packets arrives, packets can be going out. That is a queue. So what is the size of queue? There's 1,000 bytes, okay? So 1 kilobyte comes in and go out. 1 kilobyte comes in and go out. Some of the cache, for example, or buffer, you may say. So that information's here. Okay, some others more here, so we'll look at that a little later. So we can see, we can view the network configurations. The older fashion of IPA is ifconfig. Ifconfig is older ones. This is older ones. Okay. As far as I know, I do not have a recent MacBook. But if your MacBook is similar to mine, then let me bring up my, this is a terminal from my MacBook. Then ifconfig gives me the information. But when I do IPA, no command. I'm not sure yours, right? If you have a recent MacBook, you may have IP command. But mine is a little older ones, maybe 4 years, 5 years old, if not 10 years. So as I said here, IP is a new command. The old command for IP is ifconfig. So I wanted to see here the manual of man IP. Then it says show, manipulate, routing, network device, interfaces, tunnels. That is what IP command can do. Instead, on the other hand, ifconfig, it is only configurations about interface. Okay, if you compare this and that, then IP is much more powerful. Okay. Oh, I didn't bring it extra. So, oh, did I record it? I'm not sure. Let's see. Did I start recording? Oh, I started recording. Oh, thank God. Okay. All right. So let me close this. And another the network configuration information can be found from iwconfig. So if we do iwconfig, someone may guess, if we say ifconfig, if we know ifconfig, then we may be able to see iwconfig, and W means wireless. Therefore, if we do ifconfig, then it shows me about wireless LAN informations. Okay, very similar to the information that we can get from IP address. If you compare this and that, each command has a little bit of a different the informations. They are not always the same. If you compare these two, then one thing that you cannot find from IP address is this Wi-Fi service ID, not SSID. So, for example, if I said, what is a command that you can get the Wi-Fi ID? Number one, IPA. Number two, iwconfig. and more than either configure, right? This IP doesn't give you about SSID, but this guy gives us IP address 192.168. Oh no, is this IP address 200? Oh yeah, there's IP address. So it gives me an IP address. What about here? No, this guy does not give us IP, right? It gives us the MAC ID and also some of the frequencies, wireless frequencies, 5.22 gigahertz. Here we do not see wireless frequencies. So wireless waves from Wi-Fi router, between Wi-Fi router and your laptop or Raspberry Pi, there's a signals sharing between them wirelessly. That wireless signal waves moving back and forth. So the frequency means how many oscillations, how many fluctuations. If it is fast fluctuations, then it's more power. Slow waves, small number of hertz, small number of frequencies, then power is smaller, and then energy is very low. Higher frequency, higher energy, and there's more heat. For example, sunlight. Sunlight is really strong enough to heat you, or sunlight is just bright? What do you think? Sunlight is really, really hot, right? I don't know how hot it is, but you can tell. For example, in summer and winter, only the difference of the sunlight is a little bit of different angles from sun to the earth, right? Little bit of different angles. Because of that angle shift, the heats that we can get from sun is quite different, right? In summer, Dumont, have you ever wear that clothes in summer? Never, right? In other words, in summer you have a short waves. Have you ever that short single shots and going out in summer? And like tonight's, almost impossible, right? What is the difference? Only the sun, right? Sunlight is with us or not with us, or sunlight is a little bit of squid from us. Not directly. If sunlight focuses you directly, then Gianni, do you think you can survive? No, almost, right? We will be quickly roasted, right? So I was talking about the frequencies. 522 gigahertz frequency. Then that means per second, how many fluctuations? 5 million times fluctuations. What is the sunlight? One of the sunlights, the lowest frequency of sunlight is a red light. The lights, daylights that we can see, is a combination of all those frequencies, from red to purple, right? All the lights, so that we see, oh, they're so bright. If they filter all out and then only leave the lowest frequency from sunlight, then that is a red light. That is the lowest frequency. So red light is the smallest the energy light of the sunlight. The real hottest light is purple light. Purple. What is purple? Purple in the military means something, right?
No, but in medicine, purple is when someone, I believe, is suffocating.
Something like some sacrifice. I'm not sure. Purple purple metal. What is a purple metal? Purple heart.
Purple heart. Oh,
What is
yeah,
it?
yeah, no, yeah, that's yeah.
What does that mean?
Yeah. Is you mean like cold purple?
Cold is a purple.
Cold purple is when someone is suffocating. But purple heart is veterans who sacrifice their highest.
Right.
honor.
So purple is at the highest frequencies,
Yeah.
which means the highest energies.
Yeah.
Anyway, that is frequencies. Sunlight is, I think, maybe million. That's That's 5 billion, right? 5 billion fluctuations. Sunlight is 5 billion times 5 billion. So when we, for example, in summer, when you go outside under the sun, you feel really hot, right? It's not really heating from other than that. All right, so we can see that. From IWconfig, we see what else that we can see. Here, bit rate. So how many bytes? How many bits? 390 million bits per second. This is data rate to transfer. This is transfer power, 31 decibel over million power. We do not know much how big it is this, but anyway, this is some of the units. Okay, retry short limits 7 times. Receive and transfer threshold of fragment of power management on, and so many different informations about wireless communication. Rather than here, only, for example, link ether. Anybody here? Hi. Taken network class? Raise your hand. I'm not asking you, but I need to see. You're taking a network class? Okay. Then you may see that, right? Link and ether. Okay, Melody. Can you explain? No, I'm not asking. Can you explain as much as you can explain? Not as much as you know, but as much as you can explain.
Only word I have in my head is connectivity.
Okay, thank you. Okay, so that is a link layer. Okay, link layer in OSI, international, the standard, international standard of networks, 7-layer architecture. So how hard? What is the out of 7 layer? What layer? The link layer.
3.
Omar said 3. Melody said 2. Well, we'll see that a little later. 2 or 3, yeah. Ethernet. What is the Ethernet link? Ethernet, as I said, the Ethernet link, then that means linked layer, right? So they are talking about the same layer. So we will see that. And then this is the IP address. And here a prefix 24. Oma.
This tells you,
Something, right?
well, when it's at the end of the IP address, it tells you that this goes up to the range.
Okay, thank you. Yeah, we'll see that also from the command. And I'll explain it, what it is. I'm not challenging you. So this kind of things is something about network, okay? Dynamic, no prefix routes, WLAN. Okay, and here IWconfig gives us something. Okay, so that is about this. So we'll learn something about this. This wireless informations, we'll look at this a little later, not today, right? So let's move. So we jump into the IP command. So here I am going to bring up manual of IP, man IP. IP command followed by some option and immediately objects. So let's take a look at some options. One of the options is address that we looked at, right? So IP, you can say address in full, or you can simply say A. That works also. So this we looked at. It shows us multiple blocks of network interface, including interface. So number here based on the interface. Okay, in this case there is a loop back. In this case this is Ethernet. This is a wireless LAN, which is Wi-Fi connections. So 3 blocks of information that can get from this address. So when you have these options, it gives us protocol, address on a device, we're not going to look at all of this, of course not, but some of this, link layer. We'll look at the sum of the network at linked layer. Okay, linked layer. That is a layer 2. Layer 2, linked layer. And then monitor, watch network, watch for net link messages. This monitor is also important, right? And also neighbor. This is a good option. When you do IP neighbor, then it shows us who are my neighbor. Let me show you quick. So here, IP. Only 201 and 202. Whose IP is 201 right now? Probably yours is now, right? And 2. Only, so 1 reachable, this is a stale. 200 and 192.168.200.2. Mine here is 4, right? 192.168.200.4. Someone here probably 2 and 1. So we'll look at that, a neighbor. That is also very important as a network administrators. And then route. Wow, this is important, right? Routing table entries, so we may be able to look at. And then rule, that is for rule. We'll look at this next time. Stat, some of the statistics, that is also good for us to look at. Okay, those are things that we'll look So, ways to find my IP address, which is the command that we can see my IP. We can use one of those. Okay. So what I will show to you here. So first of all, if you say host name and -I, then we may be able to see this is me, right? While these are my neighbor. And the other one is IP address information. Oh, this is also good. Route, IP route. Let's look at this. Default, if we don't say anything, when I try to see routing information, that it comes through 192.168.201, which is this. So this is not, probably this is a gateway. Okay, this is a gateway. That IP is a gateway. Through this gateway, I go with the wireless LAN, and protocol is DHCP, Dynamic Host Computing Protocol. Through that DHCP, we will receive our IP dynamically assigned. So that protocol is currently based upon this protocol. This is the source. Source IP is 192.168.204. Of course, that is the source that we know, right? And then it goes with 192.168.200.0/24. So to that WLAN, the routing can see only according to this, if we say 24, OMA, so there is OMA's expertise. If we say 24, then from the beginning, how many bits of this IP address? There are 4 blocks, right? 3 dots. So first one, 192. 192 out of 255. 0 to 255, right? That's 1 byte long. If it is 1 byte, how many bit? 8 bit. So we have 8 bit here. And then another 8 bit here. And another 8 bit here. And then lastly, that is also 8 bit. So totally 8 bit. If we have 4 over 8 bits, then how many bits? 4 times 8? Doing the calculator? 32. Thank you. 32. But we said here 24. What does that mean? Out of 32, 24, which is the first, second, and third bytes. First 3 bytes. In other words, first 24 bits are the network fixed. Something that we can handle is the rest, which is the last byte here, 8 bits. So how many hosts that we can assign according to this DHCP? Whole 8 bits, right? So 256. But we are not going to assign whole 226 host IP address, but we specially reserved the first one and the last one. It's not going to be used. So first one is dot 0, right? The last one is dot 255. Those two IP addresses will be reserved. Those two addresses will be reserved for what? The IP router needs to know which one is the first one, which one is the last. So it doesn't increase further. It doesn't decrease lower than that. So first one and the last one reserved. And anything in between, free to use. So how many? 254. So in this, our protocol, according to our protocol, because it says this, how many hosts are available? 254 hosts are available. So I am one of those, right? Out of 254, we reserved the 0 out. We reserved the 255 out. So mine is 4. That is somewhere in between, right? So I am there. I am in this range. When I say this, I am there. Protocol link source that, okay. But when I do even further, as I said here, get 1.1.1.1. There will be some IP address 1.1.1.1, right? I do not know where that is. But when I say IP route get 1.1.1.1, that router, my router, try to find out. So that as the router tries, we may be able to see how it tries. So we can see that, the result here. Oh, very quickly. So this 1.1.1.1 now routes via this gateway through this protocol WLAN from 192.168.204, and then UID is 1000 and cache. It didn't go up further, right? We can do that for others like 8.8.8.8. Usually that is a Google, right? Because that's the same thing. If we can find out, for example, okay, this is a Morse address, IP address. So I want to see it's not. I want to push this a little aside. And then 23.185.0.1. Oh, still doesn't go further. So we'll look at this a little later. Oops. But anyway, so that is IP write. We'll look at the IP write a little later. I explained that here. See what it is. When you do here routes 111, so it gives us like this, right? So 1.1.1.1 means that's a destination. I can put in here any IP of the destination in my mind. It via this gateway. In our case, via 192.168.200.1. This is a gateway of our network. And then this is an interface, WLAN. and then this is the source. So where I try to find out, this is my address, right? In my case, this is my address. And the UID, this is a querying user ID. So it matter with the policy routings. So 1,000, all the time 1,000. It's not really all the time 1,000, but right now it is 1,000. Cache and expires. Cache means it is still, it went through, but not yet expires. I think two options, cache or expires. So when you do IP route get 1.1.1.1 or any other IP address, it means my question to kernel, if I send the packet to 1.1.1, what route will you use? So we know from that, the result of that, we know what is the gateway that we use, what is the protocol that we use, and where I start from. That information, right? All right. And then there is a link. As I said, linked layer is here. It's not really clear. Enough? Let me bring this a little bigger. Okay. This is a 7 layer. First, lowest layer is the physical layer. One layer above, that is the data link layer. This is a physical addressing, which is a MAC address that can be found here. Above that, you may be able to see all of this. If you're working on Windows, you may be able to see only the information from this network layer and above. If you are using Mac, then you can see the data link layer as well. Physical layer, that is not, it's nothing to do with your laptop. This is a physical linkages. I cannot see here, I cannot read, but Chris, can you read this? Can you read it?
Fiber channel, frame relay, HDLC, triple P, Q.9 to 1, and token.
I know some that you have heard of it, but not all, right? So we'll see 802.11, that is our internet connections, so we can see that. And then one level above that, from the network layer, then everyone heard of it. IP, ARP, address resolution protocols, IP security, ICMP, interconnections, some manipulation protocols, ICMP, and the transport layer. So your IP can be found here, network layer. Transport, this is like port numbers, so that TCP, UDP, so port is needed. Not only IP together with the port number, so that we can see it TCP or UDP or SSL, TCL. There's a transport layer. Session layer, who even though there is the same port, session layer tells us who uses that packet. Into the same port, multiple different packets can come in. Some packets for melodies, some packets for Timon, some packets for Omar, some packets for Eric, right? All different, right? That's a session layer. Session layer tells you where it goes. And presentation layer. So when packets comes in, it's going to use what applications, what presentation, HTML or JPEG, MP3, that type of things. If that is HTML, then are you going to render it using Google Chrome web browser or all different kinds of the web browsers, right? Application. So specific application is very on top. And some of even for the for example HTML, you may use different web browsers. That HTML comes into the presentation. Okay, that IP command that we are going to use here, data link layer. So we call that link. Okay, link. So I'm going to squeeze this back, and then IP minus S. Minus S, this is an option. S with this option. So as traffic control bytes and some, I cannot read. You may be able to see this, right? Some of the options. So more information about this. So we will be able to see that. The difference between with the option or with no option. Okay, so when I push this back and then run here, so we can try IP and link. If I do IP link, then we can see some. IP link show, I think it's the same information. When I specify a specific interface WLAN, then I think only something about WLAN. Okay, something about WLAN. So that is this. Little more than that? I think a little more than that. So this WLAN will do broadcast, multicast, up, lower, up. MTU, as I said, is a maximum transmit. Some of the, I do not know what it is. And states is still up. And mode, dormant. It's not. Okay, group default, QLAN 1000. Link and ether. So this is a linked layer. And I think this is a MAC address. In the linked layer, then we can see the MAC address, right? 2CCF and that. This is a broadcast address, all FFF. That tells about, this is some information about the linked layer right now. But if we put minus S, little more, right? In addition to this, with this option, then we can see receiver and transmit. How many bytes, how many packets? Right now, that packets, that many packets received, that many packets transmitted. No error, no dropped, no missed. How many multicast? 32 multicast. And how many collisions? No collisions. So far, so good, right? So we can see this in different number when I do. See here 32. Right now 3249. And different packets, different number of packets comes in and goes out, right? So that tells us about linked layer right now, okay? Through the IP command. So IP command is very, very strong. So I explained that here it says IP link show WLAN something, right? Interface, name, index, MAC address, status flag, up, down, lower, up, MTU, Q setup. So MT is the maximum transmit units. Q setup, what is that? Q settings. I think that is this Q settings. That is according to, I think this is some of the algorithms, right? So this is the key, this is the value. States, out of this states, up. I think out of this whole, up. So I want you to think another command, watch. Watch runs command repeatedly every 2 seconds and update the screen. That's what it is. Watch minus n. 2. So every 2 seconds, whatever the command that I have here, that will be updated. Okay? So one of the example is watch minus n 5. We need to look at first. What is DF? DF tells us man DF. That is report to file system space usages. So DF minus H, DF minus H. This is human readable. Simply DH, then this gives you more about some of the numbers, right? This is more what percentage that we used. So this is my Raspberry Pi, right? Raspberry Pi firmware. This is my operating systems. Operating systems used 16%. Size is 510 megabytes. This is my SD card. SD card, only 6% used. The size is 105 gigabytes available. How much that we used? 6.5 gigabytes. Together with that is the size of my SD card. Only 6% used. That's a DF. But if you want to use that, okay, continually, monitor that, then there is a command called watch minus n. I would say here 1 second. Every second I want to see DF minus H. If something happens, then in this case it's not going to change much, right? So I want to quit it. What if I use that? For example, IP, link, I want to see minus S. What did we use? Show, WLAN, 0. It keeps changing, right? Look at this. Every second, then we see this. Although we don't do much, my Raspberry Pi don't do much, right? Only, but operating systems and some of the applications, some of the kernels, it runs by itself. So packets are going out and coming in. That we can monitor that. Every second, I want to see the difference. So 3 packets dropped somehow here. When we receive, as we receive 3 packets. Okay, that's something that we can do for using IP. and watch it together, combined, then we can see more. Here minus D, D flags highlights some of the changes. So in this case, we don't see the changes, right? So if we want to do more, here minus D, there's some changes can be highlighted. So quickly, then you can see. So that command touches linked layer, network layer number 2, data link layer, looking at the data link layer, and then analyze the packets. Okay. Question so far? Let's move. Where's to find the, my IP address? So we looked at IP route, Nmap, then we will do maybe next class. We looked at already IP route, right? IP route minus N, route minus N. This is a, not IP, but route itself. So we have here IP route, and we can see that. And if we do, there is a command route, route minus N. You see a little bit different informations, right? Here destination 0.0.0.0, gateway, clearly it says the gateway is this. We can see here, by looking at this, we may be able to see, oh, this 192.168.200.1, that is the gateway, right? But this guy clearly tells us. And flags and G matrix 600, the same as this, right? Yeah. So I explained here what is the default. Defaults, this default routes via, then this is about gateway. Metric 600, there's a priority of a route. 600 is fairly typical. So if you say metric 600, the priority number 600, then that is typical. Yeah. So this is IP command that I ask you to do. Try to do this IP link show, IP address show, and IP neighbor. So what is the difference between IP link show and IP address show in terms of OSI layer and information types? Here, do you have a Raspberry Pi?
Yes.
You have a Raspberry at home?
Yeah, I'm connected to it right now.
You can see. Yeah, I want you to. The commands is here. I have 1, 2, 3, 4, 5, 6 commands, right? Oh, one thing. There's a monitor. Yeah, monitor is okay. let me show you this monitor. Monitor needs pseudo. Okay, so I show here IP. IP monitor, all but pseudo. Let me show you here. Pseudo, IP, monitor all. It comes out. Something happens, then it comes out. So as a network administrator, you can, for example, after lunch, if you are drowsy, then you sit back and turn on that once. I want to monitor IPs and sleep, and all of a sudden look up. Nothing happens, but oh yeah, something happens, right? 200.2 something, right? They are neighbor, not from my router. My neighbor is doing something. That's what it is. So here group work, probably we cannot do that group work. I really need to do group work. If we have enough time, then we can do that. That will be your maybe homework assignments. So summarize what layer, for example, link, network, or neighbor, each command belongs to, and identify which commands best to help detect a failing IP Wi-Fi connections. So I have 3 questions. Looking at this, the result, and you can write your answer with the evidence. Evidence is a screenshot of the result of this. Okay. I have I think 2 more slides to finish, but we have only less than 10 minutes. Here's CIDR, classless interdomain range. This is something that I explained from the beginning today. Some of you may be, what is talking about? Something about this. 192.168.1.0/24. You need to, by looking at this number, you need to answer what is the network address? What is the broadcast address? How many hosts will be available to assign? Usually if it is 24, then the 4 byte long, which is a 32, then how many is available right now? So that is 32 minus 24. So 8 bits available. So 8 bits can produce 2 to the power 8, then 256. So how many hosts? You need to do 2 numbers are resolved, 0 and 255. So anything in between. So 200, 254. Without having to say that's always possible, always it. So how many? That's what it is. The following slides, I explained that. So /24 means first 24 bits identify the network. So this 192.168.1, that is identified from outside into my subnet. First 3 numbers are identified. Okay. Leaving 8 bits for host addressing. So the last one, because it says 24. If it says 31, what happens? 31, then 32 minus 31, then only 1, right? 2 to the power 1, then there is a 2 hosts. But first and last out, then no available. Anyway, mathematically, 2, right? That type of things. If you say 30 out of 32, then 2 bytes available. So 2 to the power 2, then 4. So first and last out, then still you have 2 host numbers possible. What are those two? Then it specifies whatever that is. If it is 0, then from 0, 1, 2, 3. So 1 and 3 out. So 1 and 2. That is your IP address. So as I said here, if you say 24 prefix, then the total available address is 192.168.1.02, 192.168.1.255. Okay, then the first number 0, that's a network address. The last number 255, there's a broadcast address. So what is a network address? I explained that here. Network address identifies the entire subnet. So by knowing that whatever that number, first number, if it is 0, then the router immediately see, oh, that number is the start number of that specific subnet. Okay, so it comes into my subnet. The broadcast address, that is the last IP. The broadcast address is the last address in a subnet. So it is to send messages to all hosts within that subnet. We can tell that in specific command ipcalc. ipcalc. So if you do not have ipcalc, you have to install it. Sudo apt install ipcalc. Let me do that. Sudo apt install ipcalc. I already installed it so that it shows me, oh, you're okay. After that, I can say ipcalc 192.168.1. That's where I am, right? If I say with the 0, instead of 20, let's do 24. And I'm going to explain that. If I say 24, then the bits used up to 3 numbers of IP, 24 bits. So those are all used. Whatever left out, that is something that I can play with. Okay? What that means is that these first 3 bits are all used. We set 1, 1, 1, 1, 1, 1. 8 1 start, 8 1 start, 8 1 start. They're all used, right? What is flexibly left over? This. 8 bits are now useful. So wildcard, on the other hand, there's an opposite. This is useful. So having that, 192.168.1.0, this is the first number, right? That is IP-wise, that is this. This is the gateway. This is a broadcast. This is a network. This is a broadcast. The last ones. Last one means everything is set. I wanted to look at this, the last byte. 000, that is given, right? The first, the minimum host number is, so out of this 0, starting from 1, which means 000001. 254 means everything ones except 0. Then there's 254. If we all bits set 111111, which means then there's 255. That is not going to be used, right? There's a broadcaster. So anything in between this and that, we call that host minimum and host maximum. So your router assign the IPs, dynamic IPs, within that range. You can change that for your practice. For example, 30, as I said, 30. Then what happens? 30, then 2 bits only are available. So your minimum host is 0, 1 here and 1, 0. 0, 0 will be used the first gateway, not gate, yeah, the first minimum, what did we say that? It is called network address and broadcast address, right? So this is a network address, and this is a broadcast address. Only the host that we can assign is those two numbers, 192.168.1.1 or 1.2. All right? I may explain this one more time. Okay? That's it for today.